press the bell icon on the YouTube app and never miss another update.
Hello students, so welcome to part 18 of part 19 of the chapter Electrochemistry. In this class also I am going to continue with the discussion on competitive questions. So question number 26, efficiency of a fuel cell is given by. So efficiency of a given cell, so efficiency is equal to efficiency of a fuel cell, it is equal to delta G by delta H into 100, delta G by delta H into 100. So delta G means standard free energy, so free energy change, delta H enthalpy change into 100. This is the efficiency of a fuel cell. So idನ್ನು ಜ್ಞಾಪಕಟ್ಕೊಂಡ್ರೆ delta G by delta H into 100 ಇದು ಒಂದು ಫಾರ್ಮುಲಾ, ಇದು efficiency of a fuel cell. It's clear? So therefore, so option fourth one is the right option for question number 26. Fourth option is the correct option. Is clear? Next, question number 27. If the standard reduction potential value of Fe plus 2 is minus 0.441 volts and Fe plus 3 is 0.771 volts, the standard EMF of the cell is, say standard EMF of the cell Fe plus 3 will give rise to 3 Fe plus 2 will be. So look here, ನೋಡಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರಲ್ಲೇ, standard reduction potential of Fe plus 2 to Fe. E naught value for Fe plus 2 to Fe is equal to minus 0.441 volts, minus 0.441 volts. Then another one is Fe plus 3 to Fe plus 2. So standard reduction potential value of iron in ferric state to ferrous state is equal to 0.771 volts. 771 volts. So what is the standard EMF of the reaction Fe to Fe plus 3 to Fe plus 2 will be? So what is its standard EMF? So look at these two values. This is the standard reduction potential value of ferrous iron to iron. This is the standard reduction potential value of ferric ion to ferrous ion. So among these two, so it has a lower value, so it acts as anode. Lower value of standard reduction potential, electrode reactions oxidation, and that electrode acts as anode. Is clear? Similarly, so the Fe plus 3 to Fe plus 2, Fe plus 3 to Fe plus 2, this acts as cathode. Hence, the standard EMF of a cell is equal to reduction potential of cathode. ನೋಡಿ ಹಾಗಾದ್ರೆ ಕ್ಯಾಥೋಡ್ ಯಾವ್ದಾಗಾದ್ರೆ Fe plus 3. Now look at the given reaction. Iron is converted into Fe plus 2. Fe to Fe plus 2. That is anode. This value. Fe to Fe plus 2. This is anode. And Fe plus 3 ion, ferric ion, that is reduced to ferrous ion. So look at the given reaction. Fe plus 3 will give rise to 3Fe plus 2, 3Fe plus 2. Is clear? ನೋಡಿ ಈ ಕ್ವೆಶ್ಚನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನಿಮಗೆ ಅವರು 2Fe plus 2 to plus 3 to 3Fe plus 2 ಈ ಕ್ವೆಶ್ಚನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. Ferric ion is reduced. This oxidation number of ferric ion is reduced. So this ferric ion, it acts as cathode because it has higher standard reduction potential value. Higher the standard reduction potential value, the electrode is cathode. So therefore, EMF cell is equal to E naught cathode minus standard reduction potential value of anode. So cathode is 0.771 volts minus 0.441 volts. This is equal to, so minus into minus plus, so 1 plus 1 2, 4 plus 7 11, 5 plus 7 12, so 1.212 volts. This is the standard EMF of a cell, 1.212 volts. Your answer is third option. So for the question number 27, third option is the right option. Is clear? Note lower SRP value, that electrode acts as anode, higher SRP value electrode acts as cathode. So higher SRP means it becomes a powerful oxidizing agent. So oxidizing agent is a substance which gains electrons. So that is why Fe plus 3 change it to Fe plus 2. Is it clear? So next, another question. Question number 28. A hypothetical electrochemical cell is shown below. A plus X molar connected to B plus through salt bridge, Y molar it is separated by B. The EMF measured is 0.20 volts. Cell reaction is. Cell reaction. A to A given reaction is A is separated by A plus X molar concentration connected through a salt bridge. So B plus, so Y molar concentration, B plus is separated by B. The EMF measured is 0.20 volts. Cell reaction is. So this is the left hand electrode, this is right hand electrode. Left hand electrode, this is right hand electrode. So nodi observe madri neevu ondu ee galvanic cell alli Daniel cell anna neevu observe madidre, so what is the symbolical representation of Daniel cell? So in Daniel cell, left hand electrode is anode and right hand electrode is cathode. So one cell representation is given. In this cell representation, left hand electrode is anode. So left hand electrode is anode and right hand electrode is cathode. So therefore, EMF is EMF of a cell is, so at anode oxidation reaction takes place and at cathode reduction reaction takes place. So therefore, so EMF of a cell bandag, what is the overall cell reaction? Or the overall cell reaction. So at anode oxidation reaction takes place. So therefore, at anode oxidation, A is changed to A plus plus 1 electron. And at cathode, so reduction reaction takes place. B plus plus 1 electron converted into B. So what is the overall cell reaction? So look here, A plus B plus will give rise to A plus B. So this is the overall cell reaction. So this is anode. So at anode oxidation reaction takes place. This element A that is converted into A plus and B plus in the right container that is reduced to B. So therefore your option is A plus B plus ion will give rise to A plus B. So fourth option is the right option for question number 28. So fourth option is correct. Is clear? So idanna chanagi gnapattukodre. Next, so illi gottaaytalla illi cell representation nodkodre. So cell representation kottaga right hand of cell is anode. At anode oxidation reaction takes place. So right hand container, right hand of cell is left hand of cell anode, right hand of cell is cathode. At cathode reduction reaction takes place. Is it clear? So this is the overall cell reaction. Next question. 4.5 gram aluminium atomic mass is given 27 AMU. It is deposited at cathode from Al plus 3 ion solution by a certain quantity of electric charge. Volume of hydrogen produced at STP from H plus ions in the solution by the same quantity of electric charge will be. So this is this problem is purely based on the Faraday's second law of electrolysis. Faraday's second law of electrolysis. 4.5 gram of aluminium is deposited. So for the question number 29, so mass of aluminium deposited is equal to 4.5 gram. And according to Faraday's second law, when same quantity of electric current, so look here, ಇಲ್ಲಿ ಒಂದು ಅಲ್ಯೂಮಿನಿಯಂ ಅಯಾನ್ಸ್ ಇದೆ, Al+3 ಅಯಾನ್ ಇರೋ ಒಂದು ಸೊಲ್ಯೂಷನ್. Another one is the solution which contains H plus. So same quantity of electric current is passed. Same quantity of electric current is passed. There same quantity of electric current pass ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ನೋಡ್ರಿ, this is anode, cathode, anode, cathode. So when same quantity of electric current is passed through both the solutions, ಇಲ್ಲಿ ಎರಡು ಕೂಡ ಸೇಮ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅನ್ನು ಪಾಸ್ ಮಾಡಿದ್ದಾರೆ. ಸೇಮ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ನೋಡಿ ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರೆ, in the one container containing aluminum ions, the aluminum deposited on the surface of cathode, the mass of aluminum is given, that is 4.5 gram. And at the same time, so what volume of hydrogen gas is liberated at cathode from a solution containing H plus? That is the question. If for same quantity of electric current passed through two solutions, one solution containing aluminum ions and other solution containing H plus ions. So mass of aluminum deposited is 4.5 gram. And what volume of hydrogen gas is liberated in the another container containing H plus? That is the question. So volume of hydrogen gas liberated, that can be measured in terms of liter. Our ಕೊಟ್ಟಿದ್ದ ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಲೀಟರ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. ಇಸ್ ಕ್ಲಿಯರ್? ಸೊ ಹಾಗಾದ್ರೆ ಫ್ಯಾರಡೇ ಸೆಕೆಂಡ್ ಹೇಳುತ್ತೆ, ಏನ್ ಹೇಳುತ್ತೆ, ಸೊ when same quantity of electric current passed through different electrolytic solutions, the amount of substance deposited at the respective electrodes is directly proportional to their equivalent mass. Directly proportional to their equivalent masses. ಹಾಗಾದ್ರೆ equivalent mass ಬೇಕು. So what is equivalent mass of aluminium? So equivalent mass of aluminium is equal to valency of aluminium is 3. So atomic mass divided by 3. So 27 by 3. It is equal to 9. So equivalent mass of aluminum is 9. Then, so what is the volume of hydrogen gas liberated at STP is to be calculated. So idanne calculate madlikke helidare. So what is equivalent mass of hydrogen in terms of volume? In volume, so it is equal to, what is the equivalent mass of hydrogen? 1.008. So what volume of hydrogen is it occupies? It is occupied by 1.008 gram of hydrogen. That is half of the molar volume. So 11,200 cc or 11.2 liter. 11.2 liter. So therefore, according to Faraday's second law, mass of aluminium by equivalent mass of aluminium is equal to volume of hydrogen by, so equivalent mass of hydrogen in terms of volume. ನೋಡಿ, ವಾಲ್ಯೂಮ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಲೀಟರ್ಸ್ ಅಲ್ಲಿ ಬರ್ಬೇಕು, ಇಲ್ಲಿ ಲೀಟರ್ ತಗೋಬೇಕು. ಸೀಸಲ್ ಬೇಕಾ, ಇಲ್ಲಿ ಸೀಸಲ್ ತಗೊಳ್ರಿ. ಕ್ಯೂಬಿಕ್ ಮೀಟರ್ ಬೇಕಾ, ಕ್ಯೂಬಿಕ್ ಮೀಟರ್ ತಗೊಳ್ರಿ. ಆನ್ಸರ್ ಯಾವ್ದ್ರ ಕೊಟ್ಟಿದ್ದಾರೆ, ಲೀಟರ್. ಸೊ ಅವಾಗ ನೀವು ಇಲ್ಲಿ ಲೀಟರ್ ಅಲ್ಲಿ ತಗೋಬೇಕು. ಸೊ ವಾಟ್ ಇಸ್ ದ ಮಾಸ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಡೆಪಾಸಿಟೆಡ್? 4.5 divided by equal mass is 9 is equal to volume of hydrogen gas liberated. It is to be calculated. So what is the equal mass of hydrogen in terms of volume? That is equal to 11.2 liter. 11.2 liter. So therefore, volume of hydrogen gas liberated at STP is equal to 4.5 into 11.2. 4.5 into 11.2 divided by 9. So here 4.2 times. So 11.2 by 2 is equal to 5.6 liter. 5.6 liter. That is your answer. Option 3 is the right option for question number 23. Sorry, 29. Is it clear? This is according to Faraday's second law. ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೋಗ್ಬಿಡ್ರಿ. ನೋಡ್ರಿ, ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿರೋದು. ಸೊ ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಇದು. ನೀವೇನು ಯೋಚನೆ ಮಾಡ್ಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ಸೊ ವಾಟ್ ಮಾಸ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಇಸ್ ಡೆಪಾಸಿಟೆಡ್ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ. ಸೊ ಮಾಸ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಈಸ್ ಅಲ್ಯೂಮಿನಿಯಂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮಾಸ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ 4.5. ಇಸ್ ಕ್ಲಿಯರ್? ಈಕ್ವಲ್ ಮಾಸ್ ಈಸ್ 9. ಈಕ್ವಲ್ ಮಾಸ್ ಈಸ್ 9. ಸೊ ಹಾಗಾದ್ರಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನೋಡಿ, ಈಕ್ವಿವೆಲೆಂಟ್ ಮಾಸ್ ಅನ್ನ 50% ಅಷ್ಟು ಡೆಪಾಸಿಟ್ ಆಗಿದೆ. ಸೊ ವಾಟ್ ಈಸ್ ದಿ ವಾಲ್ಯೂಮ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟು ದಿ ಈಕ್ವಲ್ ಮಾಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್? 11.2 ಲೀಟರ್. ಇಸ್ ಕ್ಲಿಯರ್? ಮತ್ತೆ ಹಾಗಾದ್ರೆ ಇದರಲ್ಲಿ ಅರ್ಧ ಇರಬೇಕಲ್ಲ, 5.6 ಲೀಟರ್. ಸೊ ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೋದು. ಕಾನ್ಸೆಪ್ಟ್ ಕಲ್ತ್ರೆ ಈಸಿ. ಸೊ ಹಾಫ್ ಆಫ್ ದಿ ಈಕ್ವಲ್ ಮಾಸ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ is deposited at cathode in the one container, then half of the equal mass of hydrogen in terms of volume is 5.6 liter. So that is the answer. Is it clear? Next question. A solution containing Fe+2, Fe+3 and iodide ions. This solution was treated with iodine at 35 degrees centigrade. E0 for Fe+3 to Fe+2 is 0.077 volts and E0 for iodine is 0.536 volts. The favorable redox reaction is ನೋಡಿ ಇಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರೆ. So E0 value, standard reduction potential value of Fe+3 to Fe+2. So question number 30. So E0 value for Fe+3, ferric ion to ferrous ion, it is equal to 0.77 volts. Is clear? Then reduction potential value of iodine to I minus. This also reduction potential value of iodine, it is equal to 0.536 volts. 0.536 volts. So look at the SRP values of both iron and iodine. So here iron has a higher SRP value. So higher SRP value. Iron with higher SRP value that acts as a good oxidizing agent, strong oxidizing agent. So it acts as oxidizing agent. It is a strong oxidizing agent. Lower SRP value, it is a good reducing agent. Higher SRP value is a strong oxidizing agent. Element with lower SRP value is a good reducing agent. Element with a higher SRP value is a good oxidizing agent. So what is meant by an oxidizing agent? Oxidizing agent is a substance which gains electrons. So that is why Fe+3 which gains electrons from. So here it is an oxidizing agent, it is a reducing agent. So iodide ion, so that loses electrons. Is it clear? It is an oxidizing agent that oxidizes iodide to iodine. It is an oxidizing agent, but itself undergoes reduction. Hence, ferric ion is changed to Fe+2, and so by gaining electrons from iron, Fe+3 from iodide ion, iodide is changed to iodine. So it is oxidizing agent. This is a reducing agent because it has low SRP value. It has high SRP value. Higher the SRP value, the element is a good oxidizing agent. Oxidizing agent is a substance which gains electrons. So iodide ion, it loses electrons, it undergoes oxidation. So element with lower SRP value that acts as anode means electrode reaction is oxidation. Iodide to iodine is oxidation. Fe plus 3 to Fe plus 2 is reduction. So Fe plus 3 is a good oxidizing agent. Hence, ferric ion, so that that oxidizes iodide to iodine. So iodide to iodine. Hence, first option is the right option. Iodide will be oxidized. Iodide will be oxidized. This oxidation agutte. Fe plus 2 will be oxidized, and that is wrong. Iodine will be reduced to I minus, that is also wrong. There will be no redox reaction. So your option is first option. So first option is the right option. So ಇಲ್ಲಿ ಇವನ್ ಚಾಯ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಯಾವ ವ್ಯಾಲ್ಯೂಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು? ನೀವು ನೋಡ್ತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಏನಿದೆಯಲ್ಲ ಅದು SRP ವ್ಯಾಲ್ಯೂ. SRP ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇದ್ದಷ್ಟು ಎಲೆಕ್ಟ್ರೋಡ್ ರಿಯಾಕ್ಷನ್ ಆಕ್ಸಿಡೇಷನ್ ಆಗುತ್ತೆ, ರಿಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. SRP ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದ್ದರೆ reaction is reduction reaction. It is a cathode. At cathode, reduction reaction takes place. That is why Fe plus 3 to Fe plus 2. And higher SRP value, the element is a very strong or a good oxidizing agent. Oxidizing agent is a substance which gains electrons. It's clear? Done. Another question. Standard reduction potential at 25 degrees centigrade of Li plus 2 to Li, Ba plus 2 to Ba, and Na plus 2 Na, Mg plus 2 Mg are minus 3.05, minus 2.90, minus 2.71, and minus 2.37 volts respectively. Which one of the following is the strongest oxidizing agent? ನಾನು ಇಲ್ಲಿ ಹೇಳಿದೆ ನೋಡ್ರಿ, ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ. Higher the SRP value is a strong oxidizing agent. Higher SRP is strong oxidizing agent. So among the given set of elements, lithium minus 3.5, minus 3.05, lowest SRP value. So lithium is, so Li plus is a strongest reducing agent. Strongest reducing agent. So because, so it has low SRP value. And in the given set, magnesium has minus 2.37 volts. It has the highest value of SRP among the given set of elements. So Mg plus 2 has higher SRP value. Element with higher SRP value, it is a strong oxidizing agent. So ಇಲ್ಲಿ SRP value ಎಷ್ಟು ಕೊಡಿದ್ರೆ minus 3.05 volts. It is lower SRP. Minus 2.37 volts, the higher SRP. Element with the higher SRP, it is a good oxidizing agent. So therefore Mg plus 2, second option is the right option for question number 31. Second option is the right option. Is clear? So element with higher SRP value acts as anode, cathode. Lower SRP value acts as anode. Is it clear? Strongest oxidizing agent means element with higher SRP value. Strongest reducing agent means element with lower SRP value. Very important. Element with lower SRP value is a strong reducing agent. Element with higher SRP value is a strong oxidizing agent. Is it clear? Next question. Question number 32. To protect iron against corrosion, most durable metal plating on it is. ನೋಡಿ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ. Usually iron, it is coated by either tin, zinc, and then chromium, metal plating. So more reactive elements or elements with lower SRP value or a metal with lower SRP value can be coated on the surface of metal with higher SRP value. Higher SRP value. So, this is general statement. Iron ge SRP value ಜಾಸ್ತಿ ಇದೆ, zinc ge SRP value ಕಡಿಮೆ ಇದೆ. So, among zinc and iron, zinc is oxidized, iron is reduced. So, our intention is to prevent the oxidation of iron, so rusting of iron. So, that is why zinc is coated on the surface of iron. Zinc plating ಮಾಡಬಹುದು. So, one more thing is nickel plating, it is a fact. Nickel plating, it is a fact. So, nickel plating ಅನ್ನು ಕೂಡ ಮಾಡ್ತಾರೆ. ಆದರೆ ಇಲ್ಲಿ ಬೆಸ್ಟ್ ಆಪ್ಷನ್ is zinc plating. Best option is zinc plating. So, for the question number 32, so option 2 is the right option. Option 2 is the right option. Suppose in case ಯಾವುದು ಕೊಡಲಿಲ್ಲ ಅಂದ್ರೆ ನಿಕಲ್ ಪ್ಲೇಟಿಂಗ್ ಅನ್ನು ತಗೋಬಹುದು ನೀವು. It is a fact. Is clear? So ಹಾಗಾಗಿ ಇಲ್ಲಿ usually galvanizing. So galvanizing means coating of thin layer of zinc on the surface of iron to protect the rusting of iron. So corrosion of iron is protected by electroplating, particularly zinc plating, chrome plating and also tin plating. Is it clear? So illi ಕೊಟ್ಟಿರತಕ್ಕಂತ option, best option is second option. Next question. Question number 33. An electrochemical cell is set up as, ನೋಡಿ ಕೊಟ್ಟಿರಲ್ಲ, electrochemical cell is set up as platinum. ನೋಡಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ ಇಲ್ಲಿ. Platinum, it absorbs hydrogen gas at a pressure of 1 atmosphere, separated by HCl. Concentration is 0.1 molar, connected through a short bridge acetic acid CS3COH. Its concentration is 0.1 molar. The EMF of a cell will not be zero. So EMF E cell, it is not equal to 0, because option 1, acids used in two compartments are different. Even though two different acids are used in the containers, but the condition is H plus ion concentration remains same. H plus ion, not the concentration of acid. Strength of H plus, here strength of H plus, strength of HCl, strength of acetic acid. ಇಲ್ಲಿ concentrations remain same, but HCl is strong electrolyte, acetic acid is weak electrolyte. HCl is completely ionized to form H plus and Cl minus. So concentration of HCl is 0.1 molar. So therefore H plus is also equal to 0.1 molar. But if you take acetic acid CS3COH, it does not undergo complete dissociation because it is a weak electrolyte. So here also 0.1 molar concentration is given, but this is weak electrolyte. This is strong electrolyte. Strong electrolytes are completely ionized, weak electrolytes are partially ionized. So therefore in this case CS3COO minus and H plus ion concentration is less than 0.1 molar because it does not undergo complete dissociation. That is why, so in both the containers H plus ion concentrations are different. So in case of a standard hydrogen electrode, so H plus ion concentration is maintained as 1 molar. Is it clear? So here HCl, H plus ion concentration is 0.1 molar. 0.1 means H plus ion concentration is equal to 10 to the power of minus 1. pH is equal to 1. So pH is equal to 1. But here pH is not equal to 1. H plus ion concentrations are different. So reason is HCl is strong acid, acetic acid is weak acid. Is clear? The first option, acids used in two compartments are different, that is the wrong option. EMF depends upon the molarity of the acids used, that is also wrong. So molarity use madidru kuda both the containers which contains same H plus ion concentration, same strength. Is clear? So that is why second option is wrong. The third option, temperature is constant, that is also wrong. Then fourth option, pH of 0.1 molar HCl and 0.4 molar acetic acid is not same. Yes, that is the correct option. So fourth option is the right option. So reason is HCl is a strong electrolyte, completely ionized, pH is equal to 1. H plus ion concentration 10 power minus 1, pH is equal to 1. But in case of acetic acid, so it is a weak acid, concentration of H plus ion will be low, therefore pH is higher. So pH is greater than 1. pH is greater than 1, here pH is equal to 1. So therefore fourth option is right. Yake? So EMF will same illa andre, because in both the cases and both the containers H plus ions concentrations are not same. pH is not same. That is why the EMF is not equal to 0. Is clear? Next. Question number 34. Electrode potential for the following Opsal reactions of zinc to zinc ion, E naught value, that is the standard oxidation potential is given. Zinc ion agidare oxidation potential. Fe to Fe plus 2, that is also oxidation potential. EMF of a cell, Fe plus 2 plus Zn, we get Zn plus 2 plus Fe will be. Zinc, question number 34. Zinc is oxidized to Zn plus 2 electron. So E naught value, E naught oxidation potential, it is equal to, ಇಲ್ಲಿ oxidation agidare potential value is oxidation potential plus 0.76 volts. Is clear? So what is its reduction potential? So reduction potential is minus 0.76 volts. Idu kuda gottirali. Oxidation potential of zinc is plus 0.76 volts. Reduction potential of zinc is minus 0.76. Oxidation and reduction potential, these values are same but not this side. Then second one, Fe, 2Fe plus 2 electrons. So here also E naught oxidation potential is given plus 0.44 volts. So here reduction potential is minus 0.44 volts. ಇದು ಕೂಡ ಗೊತ್ತಿರಲಿ. ಯಾಕಂದ್ರೆ ನೋಡಿ ಏನು ಕೇಳಿದ್ರೆ ಅವರು, ವಾಟ್ ಈಸ್ EMF of SL ರಿಯಾಕ್ಷನ್ ಅಂತ ಕೇಳಿದರೆ, Fe plus 2 plus Zn, Fe plus 2 plus Zn will give rise to Zn plus 2 plus Fe. So here Fe plus 2 is reduced, Zn is oxidized. So zinc acts as anode. So Fe plus 2. So here iron acts as cathode. So because reduction reaction takes place, here oxidation reaction takes place. So individual agi nodidaga zinc is oxidized, iron is reduced. Zinc is oxidized. This is the overall cell reaction. So we know that according to the consideration of SRP values, how do you calculate the EMF of SL? So EMF of SL is equal to, so E naught cell is equal to, so standard reduction potential value of cathode minus standard reduction potential value of anode. So the reduction potential of cathode and reduction potential of anode. So among these two, which one is cathode? Electrode with higher SRP value is cathode. ನೋಡಿ ನಾನು ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ತಗೊಂಡಿದ್ದೇನೆ ಇಲ್ಲಿ, ಆಕ್ಸಿಡೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ 0.76 ಅಂದ್ರೆ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ minus 0.76. Is clear? This acts as anode it acts as anode. So this is anode. This is anode. So here it acts as cathode. Cathode. Cathode is minus 0.44 volts. Minus 0.44 volts. Minus of minus anode. Minus of minus 0.076 volts. It is equal to minus 0.44 plus 0.76. 6 minus 4 means 2. 7 minus 4 means 3. So 0.32 volts is your answer. 0.32 volts plus 0.34 volts. 32 volts. So fourth option is the right option for question number 34. Fourth option is right. Then by considering oxidation potential values. So in the previous class already, so I will give you one more formula. EMF of SL that is also equal to EMF of SL that is also equal to nodi innondu formula nodre EMF of SL is equal to oxidation potential of anode, oxidation potential of anode minus oxidation potential of cathode. So anode ಯಾವುದು? And ನೀವು oxidation potential ತಗೊಂಡ್ರೆ anode is zinc. Oxidation potential of anode 0.76. So it is equal to 0.76 minus oxidation potential of cathode 0.44. 0.44. It is also equal to plus 0.32 volts. ನೀವು ಯಾವ ಫಾರ್ಮುಲಾ ಬೇಕಾದ್ರೆ ತಗೋಬಹುದು. ಸೊ ಇಲ್ಲಿ ಒಂದು ಕರೆಕ್ಟ್ ಆಗಿ ಜ್ಞಾಪಕಟ್ಕೊಳ್ರಿ, ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ. ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಳ್ತಾನೆ ಎಲ್ಲವೂ ಕೂಡ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ರಿ. ನೋಡಿ, ದಿಸ್ ಇಸ್ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್, ದಿಸ್ ಆಲ್ಸೋ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ ಗಿವನ್ so potential values are oxidation potential values. So oxidation and reduction potential values are of same magnitude but not the same. So oxidation potential value of zinc is plus 0.76 volts, reduction potential value of zinc is minus 0.76 volts. So reduction potential values ಜ್ಞಾಪಕಟ್ಕೊಂಡ್ರೆ EMF ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಹೇಳಿದೆ, reduction potential of cathode minus reduction potential of anode. ಹೀಗಾರ್ ತಗೊಳ್ರಿ. or CMF of SL is equal to oxidation potential of anode minus oxidation potential of cathode. So ಇಲ್ಲಿ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, lower SRP anode, higher SOP anode. Lower SRP anode is clear, higher SOP anode. Higher, so look here, so higher SRP cathode, lower SRP cathode. ಇಸ್ ಕ್ಲಿಯರ್. ಸೊ ಅದನ್ನು ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕಟ್ಕೊಳ್ರಿ. ನೋಡಿ, ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇದ್ದರೆ ಆ್ಯನೋಡ್ ಅಂತ ಹೇಳಿದೆ ನಾನು, ಮತ್ತು ಆಕ್ಸಿಡೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ನೋಡಿ, ಈಗ ಮೈನಸ್ 0.76 ಪ್ಲಸ್ 0.76, ಲೋಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ. ಅದಕ್ಕಲ್ಲೇ SRP SOP ಬಂದಾಗ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ. ಇಸ್ ಕ್ಲಿಯರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 35. How many gram of cobalt metal will be deposited when a solution of cobalt chloride is electrolyzed with a current of 30 amperes for 109 minutes? Now, what mass of cobalt is deposited by passing 10 amperes current for 109 minutes? This can be calculated according to Faraday's first law. So, what is the formula used to calculate the mass of an element deposited, dissolved or liberated at the electrodes according to Faraday's first law? Nodi, according to Faraday's first law, M is equal to, so question number 35, according to Faraday's first law, so M is equal to Z into I into T, or M is equal to E divided by 96,500 into I into T. Is clear? This is equal to, E means equivalent mass. So cobalt, equivalent mass of cobalt is, so equivalent mass of cobalt, equivalent mass of cobalt is equal to atomic mass. Atomic mass is given 59. 59 divided by valency is 2. It is approximately is equal to, it is equal to 29.5. Is clear? 29.5. This is the equal mass of cobalt. Equal mass of cobalt. So here, or it is approximately equal to, say equal mass is 30 divided by 96,500 into I. Current is 10 amperes multiplied by T. So 109 minutes. So 109 into 60. So in terms of second, is clear? This is equal to approximately equal to, so 20, so 96.5 ಮಾಡ್ಕೊಂತೀನಿ. So 30, so 3 zeros ಇದೆ, ಅಥವಾ ನೀವು 2 zeros ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ರಿ. 20, so here also 20. Done. 30 into 109 into 6. 30 into 109 into 6 divided by 965. 965. Again, it can be written as 9.65 ಬರ್ಕೊಳ್ತೇನೆ ನಾನು. 9.65. 9.65 ಆದರೆ ಸೊ ಇಲ್ಲಿ 0.3 ಮಾಡ್ಕೋಬಹುದು ನೀವು. ನೋಡಿ, this is equal to 0.30 into 10 to the power of 2. 10 power 2 into 109 into 6 divided by 9.65 into 10 to the power of 2. You have to cancel ಮಾಡ್ಕೊಳ್ಳಿ. Is clear? ಇದು approximately 10 ಅಂತ ತಗೊಂಡ್ರೆ ನೋಡಿ, 10 ಅಂತ ತಗೊಂಡ್ರೆ ಆರ್ 3 3s ಇಲ್ಲಿ ಮಾಡ್ಕೋಬಹುದು ನೀವು, ಬೇಡ ಬಿಡಿ. ಸೊ 6 into 3, 6 into 0.3, 1.8, 1.8 into 108 divided by 9.65. 9.65. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಇದನ್ನ 10 ಅಂತ ತಗೊಂಡ್ರು ಕೂಡ, ಇದು 10 ಅಂತ ತಗೊಂಡ್ರು ಕೂಡ, ಇದು 100 ಅಂತ ಕೂಡ ಇದು 10 ಆಗುತ್ತೆ ನೋಡಿ. ಇಟ್ ಈಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಈಕ್ವಲ್ ಟು ಆರ್, ಇದನ್ನ 5 ಟೈಮ್ಸ್ ಗಾರು ಮಾಡ್ಕೋಬಹುದು. 18 5 times 90 is clear. So therefore 1.8 into 5. So 1.8 into 5 andre it is equal to 0.9. Sorry, 9. So 9. 1.8 into 5 means 9. So it is 5 times. 108 divided by 5 times nearly equal to 21 times. Nearly equal to 21 times. Is clear? So 21 is the nearest answer. Third option. Third option is the right option for question number 35. Nearly equal to 20. Is clear? So 34 is nearest value 20 is the 20 is your answer. Is clear? Third option is the right option for question number 35. Is clear? So ನೋಡ್ಕೊಳ್ರೆ, ಇಲ್ಲಿ ಕೋಬಾಲ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಅಟಾಮಿಕ್ ಮಾಸ್ ಆಫ್ ಕೋಬಾಲ್ಟ್ 59. ಸೊ ವೇಲೆನ್ಸಿ ಕೋಬಾಲ್ಟ್ 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ವೇಲೆನ್ಸಿ ಇಸ್ 2. ಈಕ್ವಲ್ ಮಾಸ್ ಆಫ್ ಕೋಬಾಲ್ಟ್ ಈಸ್ 29.5. ನಾನು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ 30 ಅಂತ ತಗೊಂಡಿದ್ದೇನೆ. ಇನ್ನು ಐ ಕೊಟ್ಟಿದ್ದಾರೆ, ಟಿ ಟೈಮ್ ಅನ್ನ 109 ಮಿನಿಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದನ್ನ ಸೆಕೆಂಡ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ರೆ 109 into 60. ಸೊ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ರೆ ಸೊ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಅಲ್ಲಿ ನೋಡಿ ಆನ್ಸರ್ಸ್ ಅನ್ನ ತುಂಬಾ ಡಿಫರೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. 0.66, 4, 20, 40 ತುಂಬಾ ಡಿಫರೆನ್ಸ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ನೀವು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ ನೀವು ತಗೊಂಡ್ರು ಕೂಡ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಆಗಿ ಬರುತ್ತೆ. ಇಟ್ಸ್ ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 36. A 5 ampere current is passed through a solution of zinc sulfate for 40 minutes. Amount of zinc deposited at the cathode. Amount of zinc deposited at the cathode. ನೋಡಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನಿಮಗಲ್ಲಿ, 5 amperes current passed through a solution of zinc sulfate for 40 minutes. Same. So formula according to Faraday's first law. So what is the atomic mass of zinc? Atomic mass of zinc is nearly 64. So that is not given. ಗೊತ್ತಿರಲಿಲ್ಲ ನಿಮಗಲ್ಲೇ ನೋಡಿ ಅಲ್ಲಿ. For question number 36, atomic mass of zinc. So atomic mass of zinc is atomic mass of zinc is nearly equal to 64. valency 2, valency is 2. Therefore, equal mass of zinc is equal to 32, approximately 32. Exact value is 32.77 ಇದೆ. So equal mass of zinc 32.77. ನಾನು approximate value ತಗೊಂಡಿದ್ದೇನೆ. Then so another one is, so 5 amperes current passed through zinc sulfate for 40 minutes. ನೋಡಿ, M is equal to E divided by 96,500 into I into T. This is also equal to, equal mass is 32, approximately 32, divided by, so 96.5 into 10 to the power of 3 into I value 5 amperes. So for 40 minutes, so 40 into 60. So ಇದನ್ನ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ತಗೊಂಡ್ರೆ 10 power 3 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ನೋಡಿ, ಆರ್ ನೋಡಿ 60 into 40 ಇದೆ. ಸೊ ಇದನ್ನ 3.2 ಮಾಡ್ಕೊಂಡ್ರೆ, ಅಥವಾ ನೀವು ವೇಟ್ ಇಲ್ಲಿ 2 zeros ಅನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ರೆ 96,500 2 0 ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ರೆ. Is clear? 3 times 90 ಆಗುತ್ತೆ, ಅವತ್ತು 30 times 30 into 30 ಅಂದ್ರೆ 900 ಆಗುತ್ತೆ. 30 into 30 900 ಆಗುತ್ತೆ. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೋಬಹುದು. ನೋಡಿ, ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 965. ಸೊ 32 divided by 9.65 into 10 power 2, 9.65 10 power 2 into 5 into 4 20 into 6 20 into 6 or so ಇದನ್ನ ನೀವು 3.2 ಮಾಡ್ಕೊಂಡ್ರೆ 10 power 2 ಮಾಡ್ಕೋಬಹುದು. This is also equal to or approximately it is taken as 10. So 10 ones are 10 twos are 10 ones are 10 twos are. Is clear? So here 6 into 2 12 into 32, it is equal to, so 12 into 32 into 10 power minus 2 into 10 to the power of minus 2, it is equal to, so 12 into 30 ಅಂತ ತಗೊಂಡ್ರು ಕೂಡ ನೀವು 12 into 30 360 into 10 power minus 2 means nearly equal to 3.6 gram. 3.6 nearest value is 4.065 gram. 3.6 nearest value is 4.065 gram. So fourth option is the right option. So ಇಲ್ಲಿ ಕೂಡ 0.4065 gram, 65, 40, 4 gram ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇಲ್ಲಿ ನೀವು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಯಾವ್ದಾರ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ನಿಯರೆಸ್ಟ್ ಆನ್ಸರ್ ಬಂದೇ ಬರುತ್ತೆ. ಅಲ್ಲಿ ನಿಯರೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ರಿ, ನಿಯರೆಸ್ಟ್ ಆಪ್ಷನ್ಸ್ ಅನ್ನು ಹುಡುಕಿ. ಇಸ್ ಕ್ಲಿಯರ್? ಸೊ ಫಾರ್ ದಿ ಕ್ವಶನ್ 36, fourth option is the right option. Next question. Question number 37. Molar conductance of NaCl, HCl and sodium acetate at infinite dilution of 126.45, 426.16 and 91 per ohm centimeter square per mole respectively. Molar conductance of acetic acid at infinite dilution is. So same type of problem. So ಇದನ್ನು ನಾನು ಹಿಂದೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೆ, ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಲಿ. ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, NaCl, HCl, sodium acetate at infinite dilution ಕೊಟ್ಟಿದ್ದಾರೆ. ಮೋಲಾರ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಆಫ್ ಅಸ್ಟಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥವೆಲ್ಲೂ ಕೂಡ AB type electrolytes. So even one pharma unit, so number is 1. HCl, it ionizes to form H plus 1 mole, Cl minus 1 mole. NaCl, Na plus 1 mole, Cl minus 1 mole. Sodium acetate, acetate ion 1 mole, Na plus 1 mole. Is clear? So I want to calculate the molar conductance of acetic acid. So for the question number 37, molar conductance of acetic acid CH3COOH at infinite dilution, it is equal to ಸೊ ಈ ವ್ಯಾಲ್ಯೂ ನಿಮಗೆ ಬೇಕು ನೋಡಿ. ಸಮ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ CH3COOH ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಅಸಿಟೇಟ್ ಅಯಾನ್ ರಿಟೇನ್ ಆಗಬೇಕು. ಕೊಟ್ಟಿರೋಲ್ಲ ಅಸಿಟೇಟ್ ಅಯಾನ್ ಆಗಿದೆ ಸೋಡಿಯಂ ಅಸಿಟೇಟ್. ಸೊ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಸೋಡಿಯಂ ಅಸಿಟೇಟ್ CH3COONA ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರೆ ಅಸಿಟೇಟ್ ಅಯಾನ್ H ಪ್ಲಸ್ ಅಯಾನ್. Sum of the molar conductivities of cations and anions, that is according to Kohlraasch's law. ಅಸ್ಟೇಟ್ ಅಯಾನ್ ಇದೆ ಅಸ್ಟೇಟ್ ಅಯಾನ್ ಇದು Na ಪ್ಲಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬೇಕು. ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬೇಕಂದ್ರೆ NaCl ಅನ್ನ ಕಳಿಬೇಕಲ್ಲಿ. ಅಗೇನ್ H ಪ್ಲಸ್ ಅಂದ್ರೆ ಅಷ್ಟೇ HCl ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ HCl ಅನ್ನ ಆಡ್ ಮಾಡ್ಕೊಡ್ರಿ. ಅಸಿಟೇಟ್ ಅಯಾನ್ Na ಪ್ಲಸ್ ಅಯಾನ್ H ಪ್ಲಸ್ ಅಯಾನ್ Cl ಮೈನಸ್ ಅಸಿಟೇಟ್ ಅಯಾನ್ ಅಂಡ್ H ಪ್ಲಸ್ ಎರಡು ಆಡ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ Na ಪ್ಲಸ್ ರಿಮೂವ್ ಮಾಡಿ Cl ಮೈನಸ್ ಅಯಾನ್ ರಿಮೂವ್ ಮಾಡಿ ಆಗ ದಟ್ ಈಸ್ ವೈ ಸೊ ಮೋಲಾರ್ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ NaCl ಅನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಡ್ರಿ NaCl ನೋಡಿ ಏನಾಗುತ್ತೆ ಹಾಗಾದ್ರೆ. ಸೊ ಹಿಯರ್ ಸೊ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ Na ಪ್ಲಸ್ ಅಯಾನ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಇದೆ Na ಪ್ಲಸ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ Na ಪ್ಲಸ್ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ Na ಪ್ಲಸ್ ಎಲ್ವಸ್ ಇದನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಡ್ರಿ. Then again, so ನನಗೆ ಇಲ್ಲಿ Cl ಮೈನಸ್ ಅಯಾನ್ ಬೇಡ ಪ್ಲಸ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ Cl ಮೈನಸ್ ಅಯಾನ್. ಸೊ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಸೈನ್ ಇದೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ Cl ಮೈನಸ್. ಸೊ ಏನು ಉಳಿಯುತ್ತೆ ನಿಮಗೆ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಅಸ್ಟೇಟ್ ಅಯಾನ್ ಪ್ಲಸ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ H ಪ್ಲಸ್ ಅಯಾನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಅಸ್ಟಿಕ್ ಆಸಿಡ್. ಸೊ ದಟ್ ಈಸ್ ವೈ ಸೊ ಈಗ ಟೋಟಲಿ ಸೊ ವಾಟ್ ಇಸ್ ದ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸೋಡಿಯಂ ಅಸಿಟೇಟ್ NaCl, HCl, sodium acetate. Sodium acetate is 91 plus molar conductivity of HCl second value 426.16 minus molar conductivity of NaCl is 126.45. So here approximately 90 plus 425 minus 125 ಹೀಗೆ ಮಾಡ್ಕೊಡ್ರಿ. ಸೊ ಇಲ್ಲಿ 425 minus 125 ಅಂದ್ರೆ ಇಲ್ಲಿ 300 plus 90 ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಈಕ್ವಲ್ ಟು 390. ಸೊ 390 ಈಸ್ ಯುವರ್ ಆನ್ಸರ್. ನಿಯರೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ 390 ಗೆ 390.7 ಇದೆ, ದಟ್ ಈಸ್ ಯುವರ್ ಆನ್ಸರ್. ಸೊ ಫೋರ್ತ್ ಆಪ್ಷನ್ ಇಸ್ ದ ರೈಟ್ ಆಪ್ಷನ್ ಫಾರ್ ಕ್ವಶನ್ ನಂಬರ್ 37. ಇಸ್ ಕ್ಲಿಯರ್? ಆರ್ ಇನ್ ಅದರ್ ವರ್ಡ್ಸ್ ನೋಡಿ ಬೇಕಾದ್ರೆ ನೀವು ಹೀಗೂ ಮಾಡ್ಕೋಬಹುದು. ಏನು molar conductivity of acetate. So here acetate ion CH3COONA plus HCl we get acetic acid CH3COOH plus NaCl. Is it clear? I want the value of limiting molar conductivity of acetic acid. Say X in not known, it is to be calculated. So then what is value of NaCl? Molar conductivity of NaCl is given. NaCl is 126.45. Then what is the molar conductivity of HCl? HCl is 426.16 plus so molar conductivity of sodium acetate is 91. So 91. So look here. This then. So what is the value of X? X is equal to 91 plus 426.16 minus 126.45. So same answer 91 426.16 minus 126.45. ನೀವು ಹೀಗೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, ಹೇಗೆ ಬೇಕಾದ್ರೆ ನೋಡ್ಕೊಳ್ಳಿ. ಇಸ್ ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ಕ್ವಶನ್ ನಂಬರ್ 38. E0 for the cell zinc to zinc ion aqueous state, copper ion to copper is 1.1 volt at 25 degree centigrade. The equilibrium constant for the reaction is, so equilibrium constant. So how do we calculate the equilibrium constant? So according to the applications of Nernst equation, so given reaction is, so in this case the standard EMF is given, E0 value is given. So E0 value So E naught value is given. E naught is equal to 1.1 volt. 1.1 volt is clear. So for the given cell reaction, so we know that so at equilibrium EMF of a cell is 0. So E cell is equal to 0. So because the reaction is Zn plus Cu plus 2 will give rise to Cu plus Zn plus 2. So for this reaction, the Nernst equation is E cell is equal to E naught cell minus 0.0591 by N into log Kc, equilibrium constant, product by reactants. So molar concentration of zinc ion by copper ion. So we know that at equilibrium EMF of a cell is 0. So therefore E naught cell is equal to 0.0591 by N. So what is the value of N for this reaction? 2. So here N into log Kc. So therefore, log Kc is equal to N into E naught cell divided by 0.0591. So what is the value of N? So for this reaction N is 2. So 2 into 1.1, E naught value is 1.1 divided by 0.0591. It is equal to 2.2 divided by 0.06. It is equal to 2.2 into 10 to the power of 2 by 6. Is clear? So 100 into 2.2 means 220. 220 by 6, it is equal to. So 3 times 6, 3 times 18, so 7, 37. So log Kc is equal to 37. Is clear? So log Kc is equal to 37.000. It is like this. So what is the value of Kc? Kc is equal to 10 to the power of 37. This is your answer. ನೋಡಿ ಹೇಗೆ ಹೇಳ್ತೀರಾ ಹಾಗಾದ್ರೆ ಇದಕ್ಕೆ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿ. ಇದಕ್ಕೆ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ log Kc is equal to log 10 to the power of 37. What is the value of log 10 to the power of 37? 37 log 10. Log 10 value 1 37. ನಿಮಗೆ ಆನ್ಸರ್ ಸೇಮ್ ಬರುತ್ತೆ. ಸೊ ಇದಕ್ಕೆ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿ ಬರುತ್ತೆ. ಯುವರ್ ಆನ್ಸರ್ ಈಸ್ 10 to the power of 37 order go. 10 to the power of 37 order. Second option is the right option. Second option is the right option for question number 38. Is clear? Second option is the correct option. Is clear? Idu general formula. Idannu gnapittukonಡ್ರೆ log Kc is equal to NF E naught cell by 0.0591. ಇದು ಯಾವುದರಾಗಿರಲಿ. ಸೊ ಇಲ್ಲಿ relationship between standard EMF and equilibrium constant ಅಂದ್ರೆ log Kc is equal to N E naught cell by 0.0591. So this is very important. Is clear? Next. Question number 39. For the cell reaction Cu plus 2 concentration C1 Zn, it is in equilibrium with Zn plus 2, C2 concentration plus Cu. An electrochemical cell change in free energy delta G at a given temperature is a function of. Node. Same formula ಇದೇ ತರ ಇದೆ. Cu plus 2 C1 concentration plus Zn in the solid state to form. It is in equilibrium with Zn plus 2 concentration C2 plus Cu. It is in the solid state. This is one electrochemical cell. Change in free energy. So how do you calculate the change in free energy? ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಚೇಂಜ್ ಇನ್ ಫ್ರೀ ಎನರ್ಜಿ ಡೆಲ್ಟಾ ಜಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ನೋಡಿ ಫಾರ್ಮುಲಾ ಏನಿದೆ, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ 2.303 RT log K minus 2.303 RT log K. K means equilibrium constant. Equilibrium constant means, look here, product by reactants. Log product by log reactant. Or delta Z naught is equal to, so 2.3 ಅಂತ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ನೀವು, ಸೊ ಇಲ್ಲಿ ನ್ಯಾಚುರಲ್ ಆಗಿ ಹೋಗ್ತೀರಿ ಮೈನಸ್ RT LN. Product is zinc. So Zn plus 2 by Cu plus 2. This is also equal to minus RT log. What is the concentration of zinc ion? C2. So C2 divided by C1. So this is your answer. Delta Z naught or delta Z is a function of log C2 by C1. So second option is the right option for question number 39. Second option is the right option. Next question. Question number 40. Question number 40. Specific conductance of 0.1 normal KCl solution. Specific conductance of 0.1 normal KCl solution at 23 degrees centigrade is 0.012 per ohm per centimeter. Resistance of a cell containing the solution at the same temperature was found to be 55 ohms. Cell constant will be. So what is the value of cell constant? So what is value of cell constant? ಏನು ಕೊಡಿದಾರೆ, specific conductance of 0.1 normal KCl solution at 25. Specific conductance is given. Specific conductance K is given. K is equal to 0.012 per ohm per centimeter. Per ohm per centimeter. Specific conductance is given. And the resistance of a cell containing the solution at the same temperature was found to 55. So R is equal to 55. Cell constant G star will be how much? R L by A. Cell constant L by A is how much? So what is the relationship between these three? So we know that R is equal to rho into L by A. So R rho is L by A is equal to L by R, it is equal to rho into G star. Rho into G star. So G star is equal to R into 1 by rho. So R into 1 by rho, it is equal to R into 1 by rho means reciprocal of resistivity is equal to conductivity. This is equal to 55 into 0.012. 0.012. This is also equal to 55 into 12 into 10 to the power of minus 3. So 12 5 is a 60, 12 5 is a 60, 66 into 10 to the power of minus 3, it is equal to 0.66. This is your answer, 0.66 per centimeter. So this is the value of cell constant. So answer is 0.66. So second option is the right option for question number 40. Is it clear? ನೋಡಿ, ಸೊ ಇದನ್ನ ಕರೆಕ್ಟಾಗಿ ಜ್ಞಾಪಿಟ್ಕೊಳ್ರಿ. ರೈಟ್ ನೋಡಿ, ಸೊ ಅಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಕರೆಕ್ಟಾಗಿ ಅನಾಲಿಸಿಸ್ ಮಾಡ್ತಾ ಹೋಗ್ರಿ. ಏನು ಕೇಳಿದ್ದಾರೆ, ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಅವೆರಡರ ಮಧ್ಯೆ ಇರ್ತಕ್ಕಂಥ ಫಾರ್ಮುಲಾ ಏನಿದೆ, ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ ಅಥವಾ ರಿಲೇಶನ್ಶಿಪ್ ಏನಿದೆ ಅಂತ ಹುಡುಕ್ರಿ. ಸೊ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚಿತ ಒಂದ್ಸಲ ಆಪ್ಷನ್ಸ್ ಅನ್ನು ನೋಡ್ರಿ. ಯಾಕಂದ್ರೆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್, ನ್ಯೂಮೆರಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಏನೋ ಲಾರ್ಜ್ ಡಿಫ್ರೆನ್ಸ್ ಇದ್ರೆ ರಫ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ತಗೋಬೇಕಾದ್ರೆ ಬಹಳ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ನಿಮಗೆ. ಸೊ ಕ್ವಿಕ್ ಆಗಿ ನೀವು ಆಪ್ಷನ್ಸ್ ಅನ್ನ ಚಾಯ್ಸ್ ಮಾಡ್ಕೋಬಹುದು. ಇಸ್ ಕ್ಲಿಯರ್. ಸೊ ಅದನ್ನು ನೋಡಿಬಿಟ್ಟು ಸಾಲ್ವ್ ಮಾಡ್ರೆ ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲೇ ಉಳಿದಿರೋ ಕ್ವಶನ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡಿ. ಓಕೆ.